Rehabilitation is not an easy task. That became really clear when talking to Miss Claire Hunt. She shattered her elbow, she experienced real pain, and she surely needed help. Around 750,000 other people in the UK have found themselves in the same position, with a long rehabilitation process awaiting for them, and the "why am I even doing this" thought popping in their mind every single day. An injury not only causes a physical problem. Physiotherapy requires commitment, which can be hard if you're feeling depressed, especially without visible progress. It's not a secret that having to go every time to the physiotherapy studio, back and forth to be helped with the exercises, or simply do them under supervision can be a pain in the neck. And imagine if you were also given exercises as homework. The motivation just disappears. It's not a coincidence that 36% of patients don't end up finishing their rehabilitation. At the end of the day, the moment they start feeling better, they stop believing they need more therapy.
After interviewing Claire and 3 other professionals, we identified the main problems of traditional physiotherapy. Physiotherapy is a burden, especially for those with elbow injuries, as it requires a long-term treatment plan. Lack of perceived progress is another big problem, as after a year of rehabilitation, Claire was told she was not making much progress, and she could not see the likely trajectory of the rehabilitation process. Uncertainty. There was a lack of clarity for the exercises and a lot of confusion due to non-specific quantities, which is especially an issue for those with elbow injuries, as they usually have a limited range of motion. For example, after her surgery, Claire was given a metal brace and could only move in a range of 40-degree angles. This also causes anxiety due to the possibility of overexertion and causing further damage, leading to patients being unable to perform the tasks to the best of their ability, further slowing down the recovery process. A senior physiotherapist we interviewed highlighted patient inefficiency as another drawback to recovering in the set time frame. Once signs of improvements are shown, patients start adhering to exercises less, thus progress is lost, and patients start re-experiencing pain. There is also a lack of data-driven care, which would allow physiotherapists to view progress and statistics to see how patients are progressing and modify exercises accordingly. There is also infrequent contact with the physiotherapist, especially with long-term treatments. Thus, patients need to have the confidence and ability to perform exercises regularly without supervision.
We tackle the mentioned issues by setting ourselves some product requirements. First of all, we don't want patients to give up or simply forget about exercises. We will therefore set reminders and small goals to increase motivation. Ideally, the patient will reach a point where they'll want to do exercises. Second, providing quantified progression through an app allows patients to view their results and track their achievements. This results in self-confidence and satisfaction, making the process more enjoyable. Clarity is essential. Clear instructions and prompts during a gameplay provide safety and confidence when performing the exercises. As the device uses an IMU which detects angles of rotations, the movements will be determined by the range of motion the physiotherapist decided, removing the fear of overexertion. As mentioned, patients' efficiency can be achieved using daily reminders as an encouragement to achieve new levels in the game. Data-driven care will be provided through a user-friendly app with a clear layout, so patients can easily check everything they need to do. Continuous contact with physiotherapists provides constant guidance when altering difficulty of exercises, as only professionals can unlock harder levels and add weights when safe for the patient.
The device is designed to be owned by hospitals and provided to patients for the duration of their physiotherapy. Its usage follows the cycle as seen on this process slide. Our dumbbell ecosystem has 4 key components: the hardware, which includes the mechanical and electrical sides, and the software, which includes the game and the app.
Our project Smart Dumbbell is a Class 1 medical device for elbow rehabilitation using the gamification. It features an IMU sensor for motion tracking and modular weight adjustment. The key features are functionality, measures motion range lower than 10% error, and transmit very low power Bluetooth. And second, safety, IP54 rated for dust water resistant with strict factory safety tests. And third is remote access. In software, doctors can track, process, and export reports in CSV or PDF.
Our aim is to create a user-focused design. After interviewing a patient and 3 professionals, we believe that our main goals are to provide quantifiable progress for the patient, have the device be operable at home, and cultivate an environment for consistency from patients. After doing some background research into common injuries, we found that elbows are easy to aggravate. Thus, it takes longer than expected to fully recover. A game therapy device would be beneficial for patients with elbow injuries, especially those with post-trauma injuries, post-cast removal, or post-surgery. We focus on specific exercises, supination, pronation, elbow bend and extension, due to them having the biggest impact on recovery. We aim to provide patients with the ability and confidence to perform these exercises regularly and unassisted at home. We also researched other game therapy devices already on the market, Bionic and Playball. Our aim is for our device to be used at home without a physiotherapist supervision, so we learned more about Playball, a therapy ball that acts as a game controller whilst recording patient performance during exercises. Inspired by it, we decided to make a device out of an already existing object that will act as a console while simultaneously collecting data for physiotherapists. Our device is based on the simple and familiar dumbbell, which we feel will make it easier for patients to use and follow exercises during gameplay.
Main features that we believe are crucial to our designs are data measurement, the type of exercise, the power source, the method of data transmission, and how data will be stored. By expanding these features, we were able to come up with a few methods for each as shown on the table. By picking different methods from each feature, and then combining them together, we were able to come up with a design like this. Using the same method, we were able to make 2 more designs. Now that we have these rough ideas, we have to consider if they are practical, and this is achieved through the use of a design evaluation. We evaluated these designs based on 6 different requirements. The weighting of each requirement is given as shown in the table. Low cost and ease of accessibility have higher weightings to ensure that these products will be affordable for any patient in need and will not add much financial burden onto them. We evaluated each design based on these criteria. A value can be obtained by multiplying the weighting of each component with the corresponding scores. These are then added together to get a total value. We repeat the same process for Design 2 and Design 3, and by comparing the final marks, we are able to find the product that is most compatible with our philosophy and needs.
And here you can see our current design, a sleek dumbbell that prioritizes portability and maintenance. The modular steel weights you can see on each end have been designed to remove the unsightly screw thread that you usually see on dumbbells. We've chosen a knurled steel handle, which will be ergonomic for the user, which will also be robust and have the ability to counter electrical interference to protect the electronics inside. A key feature of this is we want the user to be able to access the electronics because we envision this product having a long lifespan, meaning replacing the lithium polymer battery inside is key. And for that, we've chosen an ABS tray, which will also be the material for the caps, because this is a tough and heat-resistant material which is cheap and easily formed via the injection molding process. We've also chosen M6 screws because they're easily accessible for the users at home, allowing for easy maintenance. Here you can see the dimensions of the product, which have been influenced by anthropometric hand data, meaning our product will be comfortable for the user to hold, and as mentioned before, very easy to maintain. Now moving on from the mechanics of our hardware, let's talk about the electrical side of things.
The circuit we designed can detect elbow movement in real time and translate it into the game command. At the core of our system is IMU sensor, which pick up motions and rotation, powered by a lithium battery to keep everything lightweight and portable. Then the microcontroller translates them into game input, and all movement data is sent to an app so the user can track their motions in real time. The sensor we choose is IMU, which is called Inertia Measurement Unit, which is perfect for tracking motions and orientations in real time. It includes 3 axes of the accelerometer to measure the linear moment and tilting, and also have the 3 axes of the gyroscope to detect the angular rotation. On the left-hand side, you can see a real-time motion plot as I rotate the IMU. The sensor is accurately tracking the elbow movement and is super light, make it compact and easy to hold. Plus, it's battery efficient, so you can use it for hours without charging it. Well, we choose the Adreno Nano 33 IoT as a microcontroller because it has a built-in Wi-Fi for transmitting data to app and integrating IMU for motion tracking. That eliminates the need for the extra modules, which is simplify the circuit design and keep it compact. Since our product is handheld size, space is limited, and this all-in-one board allows us to fit everything efficiently without adding components. Our Adreno code is designed to process data from the IMU sensor. The accelerometer picks up the tilting in different directions, while the gyroscope tracks rotations, both using thresholds to determine the movement. Since the system relies on motion-based input, accuracy and stability were key concerns. To prevent false trigger from small shakes, we implement a dead zone, ensure that only intentional movements are detected. Building on the previous code, we use Adreno IMU sensor to detect the movement and send commands like S, W, E, and Q over a serial connection to a Python script. This code then translates this command into the keyboard input. For example, as shown on the video, tilting forward sent an up command, and tilting backward sent a down command. Then these signals are then used to control the game.
For sustainability and ease of use, we opted on using rechargeable lithium polymer batteries as they have a high energy density and low discharge rate. Using our team, we created a single-cell lithium polymer battery charger that can be powered by USB.
The Adreno IMU sensor testing and evaluation. First is delay test. We use Adreno and the PySerial library to measure the IMU data transmission time, covering sampling, processing, increasing, and transmission. Our goal is to keep total delay under 60 milliseconds for real-time gameplay. And second is battery life cycles test. We perform charge-discharge cycle test, which is 300 to 500 cycles, and simulate high-intensity usage to assess the battery heating, stability, and safety. And our final goal is to develop a wireless, low-latency, low battery life system for smooth and stable rehabilitation training.
Now onto the game. As part of making therapy more fun, we believe that being able to connect to a game is a pivotal part of this. We knew that for the game to be playable, it should be simple and not strenuous to play. We brainstormed a few game ideas: a platformer game, a motorbike game, and a flight simulator. In the end, we decided to build a flight simulator. We came to this decision because the controls of a flight simulator align well with the capabilities of the IMU as well as our chosen exercises, with supination and pronation controlling left and right motion, elbow flexion and extension controlling up and down motion. These controls are easy for a new player to understand. A flight simulator is also fun to play, and in the interest of saving time, we decided to import the game from a publicly accessible GitHub repository and improve or change things to our desire. Although currently our game is limited to exploring a set space, we intend to make levels that have an obstacle course for the patient to guide the plane through, including a progression system, with the levels getting more demanding on the patient as they progress through their therapy journey. The data from the patient's movements are recorded and sent to the app that we built.
As we can better enhance real-time exercise tracking and provide personalized training feedback, app is an ideal tool for achieving this. Our app is built on several core functional modules. The first function is user information management. Our app provides registration and login functions to ensure data security. The second function is real-time data monitoring and summarizing, real-time receiving the motion data such as angle and force from sensors, and provide real-time feedback by plotting data in line graph, and regularly generate exercise analysis reports. The report can be exported as PDF format. The third function is community and support. This provides a user communication platform where users can share their experience and communicate with each other. To press the record button in homepage, users could see their data record each day. This gives a plot of angle of rotation in horizontal and vertical direction to monitor whether patients have correct gestures when exercising. Then there is an achievement dashboard. Once a patient is successful in achieving exercising goals, their achievement will be recorded on the dashboard. Users could use online doctor platform to consult a doctor, call him, or make an appointment. And there is a shortcut key to make a call with the doctor by simply swiping to left if patient experience emergencies during their exercise process. The final part that is worth to mention is our community module. Recommendation part comes first, where patients want to share their journey of rehabilitation and look through other stories and experience. Also, as considering rehabilitation should be more scientific and accurate, we collect the latest publications and reports. Patients could access to the latest, most efficient way of rehabilitation exercises. But sometimes reading research articles could be really boring and annoying. We provide vivid video teaching where teachers are humorous and professional. Patients can seek help from others when they feel tired or difficult by just creating a post.
As we look ahead, our immediate focus is on refining the product, improving our design and functionality. We are going to improve the shape of the device to make it more comfortable for users. And a key technical goal is to minimize the delay between user input and the device response. Faster feedback will result in a more immersive gaming experience and improve the precision of the recovery exercises. Our next task is to create a customizable obstacle course that can adjust in difficulty to keep users engaged. This will simulate real-world movements and the challenges that can be tailored to individual therapy needs. And improving the user interface for patients is crucial. We want it to be intuitive and user-friendly. This will ensure that patients can navigate their recovery exercises with ease and confidence. By looking further, we have short-term plan. For example, we plan to produce an updated version of our product. Then, we'll fully assemble them, test and iterative prototyping, ready for demo day and get feedback from patients. We also have some long-term plan. Won't be achieved in this project given the time and money at our disposal. And last but not least, we'll try our best to gain the CE marking by complying with all the relevant standards, becoming certified Grade 1 medical device, and seamless app and game functionality. Our ultimate goal for this product is to build an ecosystem with potential to help many more people just like Claire. Claire's story highlights a challenge faced by many recovering from orthopedic injuries. Rehabilitation can feel isolating, frustrating, and uncertain. Dumb therapy aims to bridge this gap by offering an engaging, data-driven, and patient-centered approach to recovery. By integrating technology with physiotherapy, we hope to improve adherence, enhance motivation, and ultimately support better outcomes. While this project began with Claire's experience, its potential impact extends far beyond, offering a pathway to a more effective and accessible rehabilitation for many others in need.
And that rounds off our presentation. We've been Dumb Therapy. Thank you for listening.